Hi everyone, welcome to Cloud on Air. My name is Jay Jenkins. I'm a customer engineer based in Singapore. In our previous session, Liam Tong talked about securing your workloads in the cloud. If you missed it, don't worry. Later today, Liam is going to do it all again for you live. In this session, Tim Sell is going to talk about data lakes. We're going to dive into its murky depths and talk about how you can make that more agile. Tim Sell specializes in agile analytics, and he's going to bring a lot of that knowledge in this session. At any time during this session, you can ask a question below, and we have technical experts standing by ready to assist. So, take it away, Tim.
Hello. My name is Tim Sell. I'm a deployment engineer for Google Cloud. Thanks, Jay. So today I want to talk about building a data lake on Google Cloud Platform and why that's a good idea, why you might want a data lake, and how we might do that. So a little bit about me. I'm working for Google Cloud. I work for the professional services team. So we work with some of our biggest clients, and we help them make the best use of the Google Cloud Platform. So today, we're going to talk about what do we mean by data lake, and we're going to talk about the purpose, a bit of the goals of a data lake, why we might want one, and then how we might sort of structure that. And then we're going to meet a hypothetical team. We're going to focus on this from the user's perspective, talk about like the type of tools they're familiar with and how that might translate to Google Cloud. And then we're going to bring that all together and sort of talk about how that might actually fit. So, what do we mean by data lake? A data lake is sort of, you will see this definition a lot in the sort of world. Data lake is a place to store a lot of data in its raw form. It needs to be able to support unstructured data. That data is generally immutable by default, and it needs to be agnostic of the tools that process that data. So that means you need it to be sort of flexible enough to work with different tools and different tool sets for the needs of the people who need to make use of that data. So what are the goals of a data lake? Like why would we like to build a data lake at all? So generally, we would like a data lake to scale to any volume. We want to be able to put as much data in it as we want. We don't really want to worry about, are we hitting certain limits? We want it to be able to process any volume of data. So all the data that we have in there, we would also like to be able to go back in time, process everything all over again if we really have to. And then we want to be able to make use of that data in a way that provides value. So a data lake, the goal of a data lake is sort of this optimization function of sort of breaking down your data into usable chunks and deriving new value, sort of increasing that utility over time. And so a sort of meta level version of the goal of a data lake is we want to be able to separate the concerns between producers, processing, and consumers of data. So in this environment, we're thinking of producers as applications that generate data. Processing is its own first-class entity. So these are applications that take data and turn it into new data. And then consumers are applications that use that data for new things for the business. Oh, I forgot to skip the slide, sorry. So some of the challenges that we are trying to solve when we build a data lake, what are they? So something you see a lot in organizations, that we have seen a lot in organizations we talk to, is siloed data. And that is when you have data sets which are living in different platforms, they're living in different formats, they're owned by different teams, and they're not interoperable. Like the data that lives in your spreadsheet does not interoperate natively with data that lives in a database or a warehouse, and or you don't have access to data that might be locked up inside applications. So how do we deal with that? How do we break that down? So this is kind of a problem because if people need to make use of data that lives in different systems, they often do sort of the lowest barriers to entry, which is often taking snapshots and doing one-off little analytics. And that is often done not in a consistent manner. So another thing that we see is siloed teams. And these are when you have people who have data expertise working in different teams. They may have access to different systems, and they might be using those systems, but they're not talking to each other. They don't know that maybe somebody from the other part of the organization has already done the same problem before, and they're not making the best use of the resources that the company has. So what does this lead to? This can lead to missed opportunities. So you have often an environment where you have an application team, they're producing an application that produces data, either as log files or it lives in some database. That maybe gets exported to a data storage layer. So there is a pipeline happening. And then that is used for doing analysis. It might be turned into a business intelligence system and processed and turned into dashboards. And then those dashboards are given to the business. And so that's a very important use case, like surfacing analytics about the health of an application to the business. But what else are we missing? So sometimes data at those different levels can be reused for new purposes. And if you're not taking advantage of that, then you're sort of you only have one sort of use case. So if you can take the aggregates that the business is using and use that to make product decisions, then you have this new value coming back into the application. And an interesting example might be, what if you have an application which is producing logs about the different products people are viewing on the website or on their application, and then you would like to build a new search service. How can you make use of what the popularity of those products are for surfacing the sort of or ranking the search results? And so you can't do that if you're not connecting all those things together. So in this situation, the people who are producing the data often don't really see themselves as responsible for the data that gets produced. So another side effect of this is the data analytics that you do have ends up being seen as a cost center. It doesn't produce value on its own. It's not generating new products. It is seen as a reporting tool, which costs a lot of money. And especially if you have a very large amount of data, that can be a very expensive cost center. And if your ultimate goal is to produce business insights, but you're not acting on those insights at the application level, then it's a very expensive cost center. So I want to take a little break here to talk about something that we have talked about in computing for a while. And this is a law came up with by Melvin Conway. So Melvin Conway, in 1968, published a paper talking about how organizations build systems. So this is his quote from his paper. Any organization that designs a system defined broadly will produce a design whose structure is a copy of the organization's communication structure. And so in that paper, he outlined an example where an organization with 4 teams was tasked with building a compiler. And so they ended up building a 4-pass compiler. And this is something that has been sort of shown empirically to be true, that you'll see this a lot. And you can kind of see how in many organizations that you are probably familiar with have this kind of effect. Like you will see this especially in data systems, because often the systems are not designed for collaboration, they were designed for isolation of responsibilities. So you have an application team, and you have sort of a data warehouse team and a reporting team, and then you have the business, and they are not really integrated in the way that they use the data that they have. So you end up with these applications which move data across the silos, but it's hard to move data back. It's hard to use it for new purposes. And you can see how this happens, like in the previous examples. So this is kind of why we started building data lakes. This is why people started thinking of it in this way. So maybe not intentionally, but this is how we've sort of come to understand it. So we had these silos, and we started thinking, how can we make more use of our data? So companies which wanted to make the most use of their data, ended up building systems which naturally allowed people to collaborate. So they have this data lake as a communication channel. So rather than having silos and communication being very difficult, they concentrated on the communication, and that allowed the organization to evolve. So a data lake is, in a sense, an application of reverse Conway's law, which is where, rather than building systems which reflect the organization, you attempt to build systems which influence the organization. So this is kind of a data lake vision or a mission statement, you can think. If you would like to build a data lake, you can think, what is our goal? If our goal is to build a data-driven organization, then we should make it easy to communicate using data. And that is our fitting function. Anything that helps that is important. So now let's have a little sort of reflection on the types of people that use data in an organization. So we're going to focus on the user, and we're going to think about how we can help those users communicate. So let's meet the team. So in a typical team, or in a typical organization, you're going to get lots of different people who make use of data. But some examples are, we have an app developer, Jan. She's interested in building applications and making use of data. And then we have Bob, our data engineer, Ned, our business analyst, and Alice, our data scientist. And all of these people have very different needs. They have different data sets, different formats that they're familiar with. They have different tools that they would like to use to process data, and it's different tools that they're familiar with. So let's go through them one by one. So Jan is our app developer. Her interest is in user and product data that can help make her product better. So typically that will look like the application database, transactions, catalog data. And then she's interested in new data sets such as recommendations, wish lists, similar users, search, things that she can integrate into her product. And then we have Bob. Bob is a data engineer. He's interested in transforming data, taking it from raw formats and cleaning it up, moving it to new formats. He's mostly going to be working with log files, transactions, product metadata, all sorts of, or every type of data you can think of. But his process is to refine that data, move it into new formats, make it available to other people. And if you are not in the data lake world and you have someone whose responsibility is to do this, often they will be reaching into databases directly. They will be writing scripts which access two databases at once and publish them to some new place. But a data lake allows that person to separate that into its own environment and sort of productionize that, do that once, keep it scheduled, make it follow dependencies. So Ned is a business analyst, and he's interested in aggregated data. So he wants data which will help the business understand how successful it's being. So if he's working with the app developers and the data engineers, what he wants is clean, aggregated data that can be drilled down by the facts that he needs. So he's typically going to be familiar with SQL. He will be using sort of big enterprise data warehouses, is his background most likely. And he wants to be able to help determine how the application connects to the rest of the business goals and other metrics. now we have a data scientist, Alice. So Alice needs clean, normalized data. She wants data which is from a very large spectrum, less interested in aggregates, more interested in accessing the raw data, but in a normalized, cleaned up format. So she's going to want things like the purchase history, click streams, reviews, and she's going to produce new models. She's going to be interested in producing models which create those recommendations, those wish lists, similar users for Jan. Oh. Okay. So Jan, Bob, Ned, Alice. So you can see that these people are going to have to talk to each other. Jan's going to need to talk to Alice. Bob's not going to need to talk to Alice. Ned is going to need to talk to Bob, so on and so forth. Basically, everyone needs to talk to everybody. But how do you make it so that they can communicate using data sets, not just going into a different room and hassling people? Like, how can they make use of this? So some of the tools that we might see people using, so Jan might be familiar with a polyglot developer. She's using JavaScript, Python, Rails. She's going to be wanting to deploy things using Docker containers. Bob, our data engineer, he's going to be familiar with open source tools, Hadoop, Apache Beam, which is similar to the open source version of Dataflow, and then Apache Spark. And then Ned, our business analyst, is going to be used to using data warehouses. He's going to be interested in Data Studio and different reporting tools. And then Alice, our data scientist. She's typically might be using Python. She's going to be using Jupyter notebooks. She's going to be using NumPy and SciPy. That's her background. So what does this look like in Google Cloud? So I don't want to go too deeply into these options because we've had a lot of talks already on how to drill down on these, and there's a lot of products. This is just a bit of a snapshot. So firstly, we have compute. So these are the tools we might be using for application development, compute engine, container engine, app engine. And then storage, cloud storage for blob storage, Cloud SQL as our MySQL, hosted MySQL. And then Cloud Data Store for NoSQL. Cloud Bigtable for massive distributed key value. And then we have some data analytics products, Dataproc, which you will have heard about this morning. Oh no, that's to come, I think. So tune in for that. And Cloud Data Lab, which is our managed Jupyter notebooks, and BigQuery and Cloud Dataflow. And then we have the machine learning tools. So we have Cloud Machine Learning, which is our managed TensorFlow environment for running and training models. And then we have our pre-trained models that sort of represent the best models known to date for natural language processing, speech API, vision API, and these are sort of pre-built for you by Google. So if we think about this from Jan's perspective, she's going to be interested in something like Container Engine and App Engine. And one of the things that she's going to be interested in specifically is treating it like a platform. So she's going to want some automated health checking, some monitoring, and logging. And these are things that are provided for free, basically. Like you have logging, it's built into the system, and it just your logs are taken care of for you. So Bob is going to be interested in things like Cloud Dataproc and Cloud Dataflow. Cloud Dataproc is interesting because if you're using ETL for, if you're doing ETL on something like Hadoop, then Cloud Dataproc is our managed Hadoop environment. You can spin them up in 90 seconds and shut them down again. You don't have to manage those clusters, and you can run multiple of them at the same time. And this allows you to invert the way you might use something like that. So rather than thinking of it as a cluster-centric model, you think of it as a job-centric model where you cater the cluster to the size of your job rather than the other way around. And so, so Cloud Data Flow is our progression on that, where rather than spinning up and managing clusters, you get a fully managed environment which you submit jobs to, and it scales, auto-scales to whatever the size of the job. And this is based on Apache Beam, which is open source. And this is our framework which unifies streaming and batch processing. And so Ned is going to be interested in data warehouses. So he's going to make use of something like BigQuery, where you have this petabyte scale data warehouse, which supports standard SQL. You can do inserts or batch inserts, streaming or batch inserts. And he can then use that to derive reports, create new segments, create new views, create new aggregates, and then visualize that in Data Studio. So Data Studio is our dashboard environment, where you can create dashboards very easily off other tools like BigQuery, and use that to surface analytics to other people. So when you create a dashboard in in Data Studio, you can then share that dashboard as if it's a Google Doc. You can share it with a Google group. You can allow other people to be editors, so on and so forth. And it's very powerful, especially for Ned, because one thing that you often see in organizations is people creating reports which then get emailed around. They're not really sure where those emails end up because they often get forwarded. And then you may have people coming back to you with out-of-date information when, if they are all using this common dashboard, you can see the authoritative source at all times. So Alice is going to be interested in Data Lab. So if she's already using NumPy and SciPy, Data Lab is a managed Python dev environment which has NumPy, SciPy included. So you create a Data Lab in your GCP project, and this will allow you to connect to it, run your analysis in a Jupyter-based notebook, and then you can integrate with other data analytics tools such as BigQuery, BigQuery, and Dataproc, and so on. And so Dataproc is another example that she's going to be interested in, because you may be more familiar with something like PySpark and the Spark ML library. So she has many options available to her. She can make use of the open source frameworks as well. So let's think about how we might bring this all together. So this is just a couple of examples of small sort of workflows that people will often encounter. So if you need to store your raw data in your data lake was likely very large, and so you need to be able to publish that data without really thinking too much about it. So Jan, our application developer, she's going to have a compute engine, container engine, app engine, and they're going to be publishing events. They're going to be creating logs. And so those events need to be processed, and then they need to be published into something like cloud storage. And her logs, she would like to be taken care of automatically. So they will go to Stackdriver, our logging framework, and then they will be exported to cloud storage as well. And then these can be used for new purposes. So another use case is just exploring data, and this is this is Alice's sort of use case. So she's going to be using Cloud Data Lab. She's going to be integrating with these different systems, and she's going to have playing around with data. And then, I mean, this is a fairly simple one, but Ned, he will be using something like BigQuery, and he's going to be creating his dashboards in Data Studio and publishing them to other people. So this is it's a bit more technical. So let's think about, what if you already have Hadoop somewhere? What if you're running your data lake in on-premise? How do you integrate that? So a really common use case is archiving. So you could say that data lakes are just a big archive if you don't make use of all the other tools, right? So this is a really good starting point. So if you have a really big data cluster running on-premise, but you don't want to manage increasing the volume of that every year, you can start offloading some of the older data to Google Cloud, and then you can start reusing that data for new purposes later. So say you have a very large on-premise cluster, you peer with your GCP project, and then you sort of export that data into your Dataport cluster in GCP, and then you process that and push it into cloud storage. And one of the advantages of cloud storage, obviously, which I think we've talked about before, is multi-tiered pricing and very, very cheap cold line pricing, which allows you to store things which haven't been accessed very much very cheaply. But at the same time, those other storage classes have the same access pattern guarantees. So you can access that in the same amount of time as you access something in multi-region. So if you do decide to process that data, it's very easy. So another situation you'll see is now that you have your data living in cloud storage, you don't need to create just one cluster. You can integrate with many clusters. So on demand, you can spin up a cluster, access things from cloud storage, and then for a particular job or for data exploration, and then you can spin up new clusters on demand based on new jobs. So I kind of want to pause again and talk about overall, what do we really see a data lake looking like in GCP? And so that's more like thinking, rather than thinking of it as just one big location where your data lives, think of it more like a project. So it could be literally a GCP project. So you have data living in multiple storage places, but starting point is cloud storage. So cloud storage is your archive. This is where you leave your old data where you want it to be stored cheaply. And then you integrate it with these other tools as you need them, and you evolve that over time. So this is your middle bit. These are your data systems. And at the bottom, we have source data. This is where your data comes from. So this might be back office systems on premise or in different stores. It might be the point of sale data. It might be social network data that you've collected from external sources. It might be lots and lots and lots of different things. And then at the top, you have applications built on top of the data platform. And so in this environment, you have new applications, and that includes generally just statistical analysis, things that you could sort of typically see as like BI stuff, or you might have data science stuff. And then you also have ad hoc queries, which is just exploring. And that is allowing people, developers, data scientists, business intelligence engineers, data engineers, even your business owners, they can ad hoc explore the data that you have available and then make use of that in new ways. And then because they have this common way of using that, they can then take their results and show other people very easily. Another thing you obviously will create with applications is mobile and web apps, and these are things which make use of the data that you've derived. And then you have internal applications, which are like possibly other microservices that feed into the web and mobile apps. So a really big part of a data lake is It's not enough to just have a big pool of data. It's not enough to just take data from the input, process it, put it into a new application. To create a really comprehensive communication pattern, there needs to be some kind of loop. There needs to be you produce new applications, and those applications feed back into the source. And this is like any network. The more you contribute to it, the more people that are engaged in that process, the more useful that becomes. So you start to refine data, and you start to think of your ad hoc analysis. You start to think of your data science as applications which produce new data sets. And this is why you treat your raw data as immutable, because rather than putting things into a database and manipulating them, you create a data set, and you start to create data sets as your handle for talking about data. Because data sets can be shared, they can be referenced, and they can be versioned. So a really common way to do this is you can either do this with something like PubSub, where you are publishing event data back into the source from apps, or you could just push it directly. But in some sense, the streams, when you integrate streaming data into data lakes, you are thinking of PubSub as your abstraction for how you move data. So this is how you move data around your business. And so if you have something which consumes a stream, this is an application that consumes things out of the stream and then pushes new data back into the data lake. So at a very high level, we have the separation between storage and processing, where storage is seen as like your permanent resource for your history, and then your processing is can be also storage of in different formats, but it is considered part of applications in a sense. Like these are the things that happen sort of more for the processing, and then your downstream applications feed back into your upstream applications. So for example, you might have a search service that you're trying to build. So you have your upstream applications publishing log data. They might be publishing their transaction data, their catalogs, and then they will be stored into something like cloud storage. And then you have processing, which takes that, exports that into a common format that can be made use of by a search engine. So maybe you have a search service which is considered basically a downstream application. And this is in the context of the data lake. So it's a downstream for the data lake, but there will be another application which it is upstream for, which takes that data like a microservice, makes use of it, exposes it to the user, and then any outputs of those searches get surfaced back into the data lake, and then the cycle continues. So I just want to have some key takeaways. The most important thing is, if you're building a data lake, you really just need to make it easy to communicate using data. And if you're a data engineer, this is literally your job. This is what you should be doing. There is no other reason to do this. And then just so you can get started, start small. Don't do everything at once. Build small applications. Start with small use cases. Start with a small set of users. And then expand that over time. Develop this communication in a cycle over time. And most importantly, focus on your user. And that includes your users are your developers. They are your engineers. They are your business owners. It needs to be easy for them to use, or they won't use it, basically. So thank you.
Great. Thanks a lot, Tim. Data lakes are sort of a really interesting way to sort of look at your data. I would like to say to the audience, at this time, there should be a little pop-up telling you to provide us some feedback. So that should be on this side of the screen. So please give us some feedback so we can make these sessions better for you. And we had a lot of great questions, so thank you so much for those as well. So what if I build this great data lake with all this data in it and have the right sort of collaboration tools in place, but then nobody actually uses it?
Yeah, I think this is actually a really common problem. And this is one of the reasons you see a lot of investment in tools like Hadoop where people build giant clusters. They have the tools. They're like, why are people not using it? And I think the biggest problem there is not focusing on the user. So if you focus on a specific use case, a specific cycle, and just build the small thing for that, then you can expand it. And that's how you grow it into the culture. Because as we saw, Conway's law is a description of how organizations will build systems that reflect them. But if you build a system to try and change your organization, you have to approach it from both directions. You can't just build the system and assume that they'll start using it. You have to sort of grow it to it. But in some ways, that's why GCP is a good option, because you don't have to spend millions of dollars building a giant Hadoop cluster. You can start off very small. You can start off with a few gigabytes, put that up into the cloud, and then start using things like BigQuery, start using things like Data Studio to help communicate in the organization better.
Right, and I suppose also by doing that, you can sort of build that sort of culture as well, right? So if you sort of start small, then give these data scientists access to this data they've never had access to before, it becomes sort of a changing event in the organization. Yeah,
exactly. In fact, I think people really underestimate how much difference it makes to be able to visualize what you're doing to your stakeholders. Right? So if you're an application developer, and then suddenly you have this really easy way to make a dashboard about how many users you have right now, and you show that to the people who own your project, they're like, oh my God.
Right.
It's really kind of surprising how often you see people not really knowing how many people are using the thing that they're building.
Yeah. There was actually this great blog post that we did the other day where an MIT research scientist, he spent up 220,000 cores inside of Google. Essentially, it was research that would have taken him a year before, and he crunched it down to a couple of days.
Yeah.
But one of his big findings out of that, obviously he got the answers to his questions, but was being able to get an answer that quickly allows you to ask brand new questions.
Yeah, because we often see people build systems for storing data like a data warehouse, but they don't really capture that in a way that can be reused. Whereas if you store things in the cloud, you often have this way to very cheaply reapply that data in a whole new way, and that's quite powerful.
Okay, so what are the primary differences between a data warehouse and a data lake?
I think it really is about that communication. So a data warehouse is primarily to capture the business state of your organization, is to sort of be able to report on the official health of things, right? Whereas a data lake is designed for reuse and for new purposes and sort of being flexible. It's kind of unopinionated, and that's very intentional. So this is kind of similar to how agile teams work. There's this common phrase where people say, make decisions at the last responsible moment. Mm-hmm. So this is why data is immutable. So you store this data in a mutable format, so you don't have to decide what your access patterns are up front. So you can transform it into new formats as you need to.
Right, and you can have multiple moments. It's not just sort of that one moment where you decide how you're going to use that data, right? Because it's always there.
Yeah.
You can revisit it at any time.
And then in that setting, you don't make a data warehouse redundant. What you do is you see a data warehouse as a projection of your source data.
Right.
And so is all of your applications that make use of that.
Okay, yeah, right, because with a traditional data warehouse, again, people sort of form that data warehouse around specific schemas, again, as you said, to sort of reflect their business rather than being sort of unopinionated, right?
They're not building something which is intended to be used by the people who need to decide what color the
Right.
widget should be. Not
Right.
that that's necessarily a thing you should do or not.
Okay. So the next question is sort of around security, but also I guess silos as well, right? So how do we secure that data if it's scattered across different systems, right? Because you want that sharing capability, right? You want that access, but you also want to make sure that information is secure.
Yeah, so that's where you start to think about. I mean, this is why another reason it's important to think of the tools that are making use of data as applications. So you have things like your data warehouse is an application that takes source data, and that application can have use GCP's IAM sort of capabilities to lock that to the people who need that form of information.
Right.
And then you can lock applications to only be able to access certain types of the source data. And you open that up to people that need it. So you have the centralized way and convention of storing and accessing your data, but it's really just a policy about who you make that available to, not where does it live. Like
Right, right.
So yeah.
And again, just because you're storing it raw doesn't mean you can't repurpose it and tokenize it. And again, it sort of encourages that behavior, right? Because you always have that source data available, but you can create these other repositories where people might have to do specific sort of work with it.
Yeah, exactly.
Awesome. So great. So I have this data lake. How do I, as a research scientist or somebody who wants to actually do something with that data, how do I figure out what's there? Do I need to store metadata in order to achieve that?
Yeah, I would actually say that this is a kind of an advanced topic. Like, most people don't need that when they start. So it's important, definitely. Like, at some point, you're going to have to start recording metadata about where your data came from. And then you need to make that searchable. You need to make that visible. You need to make that accessible as a data set on its own right.
Right. Sort of like service discovery for data.
Yeah, and but that is a thing you can evolve towards. Like, you don't have to start with that. Like, if you have like 5 data sets and then they all live in GCP cloud storage, then it's basically a directory tree of 5 things. Right? And so that will expand. It will eventually become like hundreds and hundreds of things. But if you start with your small use case, then you start to find what works best for that. So.
Right, and I suppose, especially early on, you might not want to lock that in so quickly, right? You might want to keep that free to encourage that sharing capability.
Yeah, and I mean, it's part of the nature of it is that it is designed to be a little bit freeform. Like, it's almost organized chaos.
Right.
Like, it's not the solid schema perfect version of the world that we want in a sort of data warehouse, but it's a sort of collaborative environment. So you have certain parts of your business which are very important, like your data warehouse data for business reports, and they can be quite controlled and locked down and sort of well structured. And then you have like your sort of Wild West kind of log structure, which just comes in from new applications, and you sort of do that by convention. Like, you slowly develop these conventions where it's named after the application, so you kind of know where to go look for it. But you slowly sort of mature that into sort of more official data sets over time.
All right, cool. So the last question is what about data retention policies, right? So I have all this data. How do I decide when to cut it off and throw it away?
Yeah.
And how do I actually enforce retention policies around that?
So, if your data is living in cloud storage, there's like very good tools for that. So we have our data lifecycle management around how old your data lives. You can sort of take action so it gets deleted or it gets moved into a cheaper storage class, and then so you can have like, okay, this data needs to be deleted after 1 year if it's too old. You can just segment that by the types of data, like paths.
Right.
And but for other data sets, if you've moved data elsewhere, you're still going to obviously have to sort of take care of that flowing downstream.
Sure.
So it's not an easy problem.
Exactly. I mean, I guess because the compute side is so elastic, really you're just talking about the storage, right? In terms of your holding cost.
Yeah, because if you don't have like multiple silos of data, you have this one source of your data, so you just have to delete it there, and then you have to find the places being reused in new data sets. But in terms of like, does it live in your compute resources? You just destroy them, start them again.
Okay, and I guess another thing that I was thinking of was really, right, whenever you're looking at those data policies, you need to weigh the future value of that data against the cost to store that data, right? Because the compute side's elastic. You know, in an ideal situation, you know, we have the tools available to keep that compute side elastic. The other side of that is maybe you don't necessarily want to throw it away, right? You always have access to tools like data flow, so you can always do, because you have the raw data, you can always do things like windowing. You can always do things like aggregation of that data in order to store it in a rolled up fashion, so you're not necessarily throwing everything away.
Yep, exactly.
Okay, so thank you so much, everyone. Hopefully you gave us some feedback on the side. If we could just go to yes, there we go. So there's some more information available. So please take a look at certification. So cloud.google.com/training. There are also a number of hands-on labs available from Quick Labs and from Coursera. If you have any more questions, please contact us. And there are free tiers available for our software. So if you go to cloud.google.com/free, you can try out a lot of these tools at no cost. And again, going back to big data, right? BigQuery, super cheap. A terabyte of queries for free every single month, and a lot of public data sets available, so you don't even have to store your data in order to start playing with that. So thank you very much. Our next session is going to be from Gaurav Anand, and he's going to talk about using open source data processing on Google Cloud Platform. Thank you very much.